Let's see how to check the analysis results of a connection in CYPE Connect. To do this, once the node has been created, we select it in the table on the left-hand side of the interface and edit the connection by clicking on the corresponding button at the top. In the Connection pop-up window, if the model of the connection is already complete, we go to the Analysis tab. Here, we click on Stress Deformed Shape to run the connection analysis process. Once finished, we can check the results of the analysis using the options in the corresponding group of the top toolbar. First of all, in the Result drop-down menu, we can select the maximum demand capacity ratio. This way, in the 3D view of the connection on the left-hand side of the window, each of the elements is represented with a specific colour according to its demand capacity ratio. A colour scale is available at the bottom of the window for interpretation. At the top right, in the Analysis drop-down menu, we can choose between checking the results on stress, deformed shape, or rotational stiffness. By selecting Stress Deformed Shape, a table appears below with the maximum demand capacity ratio of the elements for each type, including the sections, plates, bolts, and welds. We can also check the results of the anchors and concrete if they are included in the model. For each element, the maximum demand capacity ratio is displayed and the corresponding load case and check is indicated. The checks table is then displayed according to the different criteria of the selected codes. If desired, we activate the Only Show the Failed Checks checkbox. Here, for each connection element, the demand capacity ratio is shown in the corresponding code checks. If we click on a connection element in the viewer, we will only see the checks of the selected element in the table. By clicking on any point in the 3D view outside the connection elements, we can see the checks for all of them. Furthermore, by selecting an element type in the maximum demand capacity ratio table, the program selects the element that produces it in the checks table. For sections and plates, the deformation is verified and the plastic deformation limit is set at 5%. For bolts, checks are carried out for the geometrical layout and resistance. For pre-stressed bolts, slip resistance is also checked. For welds, the strength of fillet welds is checked. If the connection includes anchors, both group checks and individual checks are carried out. For concrete, the compressive stress is checked. By clicking on any of the checks, the program shows a detailed report of said check in the bottom right-hand corner, where the article from the associated code and the parameters involved in its check are displayed. We can share or export this information in different formats or print it directly from the page preview. Again, in the top toolbar, by accessing the Result drop-down menu, we can also obtain the von Mises stress view. Next, we choose the load case. This way, in the connection view, the contour plot representation of the chosen result and the discretization of the elements is shown. To the right of the Result drop-down menu, we can configure the view options. The contour plot representation can be discrete if we want the program to use a finite color scale, or continuous if we want it to use a gradient color scale. Additionally, we can specify limit values for viewing the results by adjusting both the minimum value and the maximum value of the scale. We can also click on any sheet to display a pop-up window with the component mesh and the results of that single sheet. The next result to be selected is the equivalent von Mises deformation. Again, for each load case, the program represents the percentage values of the deformation using contour plots. Finally, we can check the displacement values of the connection elements by means of their representation in the 3D view by selecting the load case of our choice. We can also apply a scale by typing a value into the corresponding field. Finally, if we wish to analyse the rotational stiffness of the selected bars, we click on the button with the same name to run the analysis process. We can then check the results by selecting the option from the Analysis drop-down menu on the right. Below is the sections table, on which the rotational stiffness analysis is carried out, indicating the reference, the plane including the load, the theoretical length of the bar, the secant stiffness, the limit rotational stiffness for rigid and pinned connections, as well as their classification as rigid, semi-rigid, or pinned. In the following table, load cases, we see the data relating to the load cases of the selected section, including their reference, acting moment, resistant moment, secant stiffness, and initial stiffness. A graph of the moment rotation curve is shown below, which also shows the acting moment and resistant moment, as well as the secant stiffness and the limiting rotational stiffness for rigid and pinned connections.